So before getting into the value engineering, how we can utilize this available facilities, CAE, for product improvement, we need to understand the industrial revolutions, how it happens. So the first industrial revolution by 18th century, it started with the innovation or invention of steam engine when the when where the innovation impact on the civilization. So people moved from villages to factories and started working for low wages and in terrible conditions. So it is a kind of innovation from uh, moving people from one place to other place, and they worked in a set of uh, factory environment. And the second industrial revolution, it has begun with the invention of electricity that enabled the mass production of products in various applications, especially in the automobile sectors. And followed by the third industrial revolutions, when the computers were available and the developments of computers and relevant systems were available to the usage. It enhanced the facilities or enhanced the uh, capabilities of industries. And the fourth one is also known as Industry 4.0, which is currently being discussed by various firms and also being applied in various industries. It is nothing but merging of computational facilities with the manpower, physical manpower. So it is more on the artificial intelligence, 3D printing, autonomous vehicle systems, and Internet of Things kind of applications. And this is also noticed that the Industry 4.0 is just a extension of industrial revolutions of third industrial revolution. But comparing the speed and the pace at which the fourth revolution is moving, we can clearly distinguish the third industrial revolution and the fourth industrial revolution. By discussing these various era of industrial revolutions, we can clearly see that each revolution has some new invention and new developments in technology and the applications. However, what we want to understand, what we understand from this development, even before the invention of computers and hardware software, there were so many products were being developed without the help of computers and softwares. Then at this moment, with the development of computers and hardware softwares, how it is helpful in the development of the product currently what we are manufacturing, how it is supporting the current environment, though we already have many products being produced without the support of computers, and how it is scaled up with the application of computers and relevant systems. So that is what we are discussing, or we are saying as a value improvement in product design by using the computer and software technologies at this moment. So basically what we are focusing today's discussion is the domain called as computer aided engineering, also known as CAE. It is nothing but the use of computer softwares and hardwares to simulate the product performance to improve the design of any system. and it helps to resolve the problems involved in the real-time applications, starting from a single product or single part to the complete system. And mainly the CAE used as a simulation tool, the validation method, and for optimization of product and process, also in the manufacturing aspects. So CAE is used in various industries like automotive, aerospace, electronics, etc. And there is no limitation in the application, because nowadays all the product are virtually tested or virtually modeled and tested before producing the prototype. So this is how the current industry is working to reduce the time and cost of release of product to the market. So the time involved in the development of physical prototypes and testing and validation of prototypes are drastically reduced by applying the CAE technology for the manufacturing, design and manufacturing of any system. So we can see various applications of the, the technology called CAE, starting from the stress analysis in static and dynamic conditions of individual parts, as well as assemblies using finite element analysis approach, and thermal and fluid analysis using computational fluid dynamics, and various kinematics and dynamic analysis of mechanisms of systems are also analyzed using multi-body dynamics approach, and acoustic analysis using various methods. One of the method is FEA, and various other methods also available for acoustic analysis. And another one special approach is a system level analysis using one-dimensional modeling. It is especially used for mechatronic system simulations, for multi-domain mechatronic system design. And one of the example for this kind of application is design and validation of automatic shift transmission systems. So what we call it as automatic shift transmission, it is basically a mechatronic device. It is kind of a transmission system which is which consists of gears and shaft, clutches, and all the mechanical components are operated using a set of hydraulic units, and these hydraulic units are controlled by various solenoids, also known as sensors. So these sensors are controlled by a pre-programmed control systems. So basically, all together as a system, it performs in an automotive vehicle, off-road vehicle. And in recent days, the automatic transmissions are used in passenger vehicles also. Automatic gearboxes are available. And these are the mechatronic systems. And these systems involved multi-physics environment. And so it requires such high fidelity tools for verification and validation of product as a system, not as a component. It is basically used for a system level analysis. So the whole system or the whole product will be modeled and analyzed for its performance. So based on the response output, the system will be fine-tuned further by optimizing various input parameters. So the 1D CAE approach is basically used for system level evaluation, where multi-physics environment is involved. Electronic, hydraulics, mechanical, like various other physics involved in the product. The another one, control system analysis. So it is part of a mechanical system, how that electronic control systems are being used in the virtual environment. So this is also part of the 1D CAE approach. And next one is the simulation of manufacturing processes like casting, forming, welding, etc. So there is a distinguished between the so far what we have listed on the analysis 1 to 6 and 7. Manufacturing process is like a simulation of manufacturing process that actually involved multi-physics environment. So it is not like a simple stress analysis of any product, a part or system. So the manufacturing process like welding, these are involved with uh, high level nonlinearity in terms of geometry, material, and contact. So the simulation of such process require high fidelity software and hardware. So with which we can scale up the simulation, and we can extract more realistic output through a virtual platform, which will help fine tuning the process, and it will improve the quality of the product and optimization of the products and the process. So basically, optimization, it is not actually based on a finite element method or any numerical method. It is basically a kind of soft computing method, which which is integrated with other numerical approaches like FEA and CFD. So these numerical simulations will help predicting the performance of any product, and this is integrated with uh, methods like a design of experimental approach or various other optimization process like genetic algorithm kind of things. And it will help by combining these optimization techniques with numerical analysis, uh, will help to understand the mechanisms and to understand and optimize the performance of the system. It will yield the optimized product at the concept level itself. Basically, when we do new product development, we will start with the concept design, and then it will be developed into a actual product, and then it will be built as a prototype and will be validated. If any changes required in any of the component in the complete system, we will come to know only after testing the product how that particular component or subsystem perform within a system. So this modifications, if any design change required after building a prototype, it will cost more. Also, the time utilized for developing the product is also very more. So these time and cost can be reduced by building the system into a virtual environment and testing the system in the virtual environment using the hardware and sophisticated softwares developed developed for certain applications. So based on the response obtained using the tools, it can be fine-tuned. However, the tools and softwares will help us to understand the mechanisms and the performance of the system. But it cannot replace the physical test at any cost, because whatever the software we use, whatever the hardware we use, it performs based on the given input only. And there are many uncertainty in the manufacturing side, and it cannot be bring into the software all the time. So certain assumptions we have to make while we do the evaluation in the virtual environment. So to accommodate this uncertainty in the system, in the real system, we have to do the testing uh, in a real environment, like a prototype testing and a field validation is must. However, the CAE will reduce the number of physical tests. Thereby, we can reduce the cost and time required for the complete evaluation of any system, any new system. So digital twins. So we always used to discuss on the term called CAD, computer aided design, and computer aided engineering. But digital twin is much more beyond the CAD and CAE. Digital twins are more fine-tuned replication of any system in terms of geometry, materials, and the environment in which the actual system is being deployed. So it is an integrated system or the integrated environment in which a virtual product is being developed and assigned with appropriate material conditions and appropriate material, uh, and the scenario, the environmental conditions also incorporated in the virtual platform in which the real system is being deployed. So it is more like a fine-tuned version of CAD, integrated CAD CAE environment. So with which more sophisticated systems are being modeled virtually and tested prior to proto development. So based on more accurate input, it will yield more realistic response of the system. So which will help fine tuning the system's performance at very early stage of development. So basically at the concept level itself, it will be fine tuned. If any changes required to improve the performance, it can be used to optimize the complete system. So what we are talking about, a complete system, not just a single part. It is a complete system. And we will see some of the example how the complete system is being analyzed in an industrial environment through the available tools. And in some cases, these digital twins are also used for sensitivity analysis kind of things. So basically, whatever the systems we model, it is a kind of process. So the process consists of multiple input and multiple output. So basically, each input are known as independent variable. By changing one input, it will not affect other input. Input one and input B, input one and input two. If you are considering change of parameters or change of the value of input one, it will not influence or it will not change the input two. However, if you are changing the input one or input two, it will influence the response of the complete system. So that is the dependent variable. So when we want to understand the changes in the input from one minimum value to one maximum value within a band, so we can build a digital twin and we can set up a minimum and maximum range of various input, and we can perform a sensitivity analysis of input, various input. So it will help us uh, understanding the influence of every input on the system in a virtual platform. So with that kind of fidelity, we can understand and we can fine tune the system's performance at an early stage of development. So it will help us in the improvement of product performance and the quality of the system at a very early stage of the development. So this is one of the example of 1D modeling of a system in which every subsystem and every parts in the subsystems uh, are modeled, and appropriate input are defined to each part and each subsystem. Thereby it will represent a complete product. So here, example of a vehicle, a performance evaluation of vehicle is being modeled, in which the complete vehicle environment, how that airflow happens outside the product, and how every parts and subsystems in the vehicle is performing for the given input is modeled. So every system, every input parameters should be given appropriately to get proper information about the system. So it is also a challenging task how we define all the variables, how we collect all the data. So every time we may not have all the information, or we may not able to collect all the data from a realistic condition. So in that case, we have to model, or we have to assume some of the input. And in that case, when we are changing the assumption in the input, how it affect the performance of the system. So these what if analysis can be performed when we model a virtual models of a complete system through 1D approach. So basically 1D approach is used because we cannot model everything in a three-dimensional environment as in real condition, because of the computational limitations and the software limitations. So considering that, we have to choose appropriate methodology for required applications, required verification, where to use 1D approach, where to use two-dimensional approach, and where to use three-dimensional approach, and where to use multi-physics approaches. So we have to choose the appropriate applications for certain objectives. So we should know what are the various types of evaluations available, and when to use which tool and which approach. So it is more important. So basically, we should understand the fundamental behind this. So that is what we are learning throughout the your graduation programs, and practical application of such fundamental knowledge has to be explored in industrial environment, like how the industry utilizing the technology or utilizing the fundamentals that is being taught in the institution. So this is a kind of example. So here it is basically work. It basically works based on analytical approach. There is no finite element modeling or computational fluid dynamics is involved in this one-dimensional approach. However, it is basically uh, the one-dimensional approach is nothing but a analytical method, or programmed as a software that connects multiple subsystems. So every approach will have certain limitations. Like 1D approach also will not cover complete evaluation, but depends on the objective. We can extract what are the response required from this particular one-dimensional modeling and evaluations approach. So this is another example where 1D simulation approach is connected or integrated with the CAD system. 1D approach is connected with the 3D environment. Here, whatever the circuits or 1D sketch, what we have seen earlier example, and the output of certain subsystem is given as an input to a 3D subsystem, and since it is integrated into a tool, so we can visualize and we can extract the response of the 3D system also. In many cases, whenever we do virtual analysis like finite element analysis or computational fluid dynamics, we may assume many things when we define the input, which cannot be readily available for the analysis. For example, application of a pressure to a three-dimensional object, we may assume as a constant pressure, but in real condition, it is not a constant pressure. It is a transient input. The pressure will vary with respect to time. So 0 second to some t second, the pressure will be varying with respect to time. It is not basically a constant number. In many applications, the assumption of constant pressure or assumption of constant input will not be sufficient to extract proper information from the product or system which is being evaluated. So in such applications, in such requirements, we this kind of integration of multiple approaches will help us to give proper input to a system. So the 1D environment will give output pressure with respect to time. These output will be given as an input to a three-dimensional environment in a finite element analysis as an input, which will help us to model a appropriate environment or appropriate input conditions to a system which are being evaluated. So these kind of integration and are required sophisticated software tools. Also, it will consume more hardware capacity. So the infrastructure required for such integrated systems are also very high. However, in a real condition, these kind of integrated systems are required to predict, to understand the performance of the system more accurately. So basically what we are talking about is a kind of structural analysis applications I'm presenting here. So the part level analysis, the evaluation of a single part. We start with a single part, but it is also applicable for a whole system. One example is the weld structure, deformation behavior. This is a structure when we model into a CAD. We have to consider the manufacturing methods through which it is manufactured, because we do not know the influence of manufacturing process on the system. So in general, we neglect this at the concept level design, concept stage. But manufacturing process like welding, casting, forging, kind of a process in which the material nonlinearity is highly influencing the strength of the material, will influence the design. So it is in critical application, it is mandatory to understand appropriate characteristics of designs that are manufactured using different processes like welding, forging, castings, kind of thing. So in this picture, you can see that the experimentally manufactured components through welding and simulated uh, parts through the same process. And the deformation, you can see the deformation after the welding process. Uh, it cannot be predicted before simulations. We cannot understand how it will deform or how much deformation will happen after the manufacturing of this product or parts through welding. So to understand the deformation behavior, a simulation will help us to implement such manufacturing process in a virtual environment, and we can predict the system. Apart from deformation, this welding will introduce a lot of residual stresses into the component, which will degrade the strength of the material or being welded. So the degradation of material and the quantity up to which the material strength is degraded has to be evaluated prior to applying any manufacturing process or any developing any designs through such manufacturing process. So virtual validations or virtual platform will help us to understand such deformation behavior and a kind of residual stress present in the product after welding can be analyzed in a virtual environment prior to developing a physical protos. Apart from that, the next image, which is shown as a vehicle chassis structure, which is actually welded with multiple small components, because if you are taking any structure, big structures, it cannot be always uh, a casted product. We cannot cast a complete structure. We can cast a smaller parts, or we can forge smaller parts. Then we have to connect the smaller parts into a bigger structure. In many applications, welding is one of the cheapest method of manufacturing uh, to assemble or to manufacture a bigger system, bigger structures. So in that case, manufacturing process that introduce some of the deformation and residual stresses inherently. Apart from that, external loads are external loads will act on the complete system along with the inherent residual stress and deformation. So without understanding proper influence of such manufacturing process on the components, if we are evaluating a system, it will not give us proper or appropriate result. Thereby, virtually it may pass, but practically it will fail. So it requires proper input and proper understanding of the manufacturing process in the design stage when we are making a concept. So it is an integrated environment in which when we are doing a virtual design, uh, we should have the understanding of the manufacturing process, and we should consider appropriate input uh, to the virtual analysis, considering the manufacturing with different manufacturing processes, which will help us uh, understanding, or which will help us resolving some of the challenging problems involved in product development. Another one example, as shown here, is the heat treatment process. So heat treatment, which is used for improving the strength of any material, basically heat treatable material. Uh, so we can have a low strength material by default, which in which the application of heat treatment process will help us improving the strength by altering the microstructure and its phase conditions. So the optimization of manufacturing process can be done by using the virtual evaluations. So whatever the simulation examples we are discussing here, basically all the simulation process will let us know one thing, that it is helping us to reduce the cost involved in the overall product development and the time involved in the product development. Thereby, it will help in developing a product in a shorter duration of the time. And these are some of the applications. A dynamic simulations are used for various applications like gearbox, lubrication system, and sloshing of fuel in an engine, or lubrication, or sloshing of lubrication in engine. So basically, when we are these lubrication systems are very important to understand how the lubrication is happening within a system, because it is the lubrication system is basically used for reducing the friction between two or multiple contact components, as well as it is also used for taking away the heat or dissipating the heat from the components of the system. So understanding the lubrication is very important in such applications. We cannot uh, really visualize what is happening inside a gearbox or inside an engine from the physical prototypes. So in such cases, a virtual environment or virtual simulation approach like computational fluid dynamics, or a combination of CFD along with a finite element analysis will help to understand the performance or the mechanisms of the system, how the lubrication happens within the gearbox. Uh, so that can be arrived by using CAE. So based on that performance, we can alter uh, where the lubrication is required, and how we can modify the system in such a way that a region or a component will get the lubricant within a system. So such modifications can be uh, made based on the understanding of the system through virtual environment. So what we are seeing in the below image, like a gearbox simulation, we can see that the machine gear that is taking away the lubricant from the sump, and it is lubricating the gear teeth. However, we can also see some of the lubrication or some of the lubricant is also flowing through the inside holes of the gear. So if the hole is not provided in the gear, this lubricant flow will not happen through that hole. Thereby, the bearings mounted just below the gears will not get sufficient lubrication. In that condition, the contact components, the bearing rollers and rolling elements and the raceways will be heated up faster, and it will reduce the life of the bearing. So this kind of understanding, by providing various changes in the design of parts, we can simulate a system, and we can understand where the design change is required, uh, how we can give the how we can provide such provision for lubricant to flow around the bearing, such that the life of the component, like a bearing, can be improved by reducing the temperature produced by the components. And the image what is shown just left side of the gear simulations is nothing but a pressure developed between two meshing gear tooth. And this is one typical problem involved in the lubrication systems, especially in the gearboxes, where the insufficient lubrication will lead to larger friction, thereby it will increase the wear of the component, and temperature will increase, and it will lead to worn out of components. If the lubricant is lubrication or the oil flow is very high, it will form a very thick layer between meshing teeth, and it will lead to a power loss in the gearbox system. So it is also known as a churning losses in the gearbox, churning losses, which is power loss due to lubrication system. So in such applications like a gearbox lubrication, the amount of lubricant should be optimized in such a way that the efficiency of the system can be maintained with lesser power loss. We cannot eliminate a power loss in a system, but we can reduce the power loss in a system by optimizing the amount of oil flow or lubricant flow between two meshing gears. So the system should be designed in such a way that it will allow sufficient amount of oil or lubricant within a gear pair, within a meshing gear pair, in such a way that it will reduce the friction between the component, as well as it will take away the heat from the components. So these are some of the softwares widely used in various industries for one-dimensional simulations and scripting. There are many products available, and these are some of the widely used product. Amazing is the Siemens product, and another MATLAB and Simulink, which is the scripting as well as 1D simulation environment for scientific calculations for system level modeling applications. And Scilab is the it will a kind of software which can replace the MATLAB. However, the Scilab is the open source software which can be downloaded for free of cost for part developments or any industrial applications and academic research. And the Python is a programming language which is which is also a open source software which is widely used for scripting applications and analytical calculations through developing computer programs for various calculations. So these are the simple softwares, but effective softwares which is widely used in industrial environment. And there are some of the pre and post processing application softwares available. Some of the examples or some of the widely used tools are FEMAP. FEMAP is again the Siemens product. Actually, this FEMAP is the pre and post processing software which is mainly used for finite element modeling, meshing applications for finite element model analysis simulations and post processing applications. And it is independent pre and post processing software, which means that it can be connected with any solver like ANSYS, Abacus, like any solver can be connected with the FEMAP. So once we mesh using FEMAP, it can be used for multiple simulation applications. We can connect various solvers, dedicated solvers, because one solver cannot be solve all the problems. For certain applications, we have to choose the right solvers. So FEMAP kind of softwares like dedicated or independent pre-processing software will help reducing the meshing time, because once we mesh using a dedicated software like a FEMAP, you can connect any solver and you can carry out any different simulations. And Hypermesh and ANSYS is another widely used pre and post processing software in an industrial environment for automotive and aerospace applications. And one more thing is on the FEMAP, it is actually available for free of cost for all the engineering institution for academic research. So you can download and you can use the FEMAP. You can learn FEMAP, which will help uh, understanding your pre-processing competency, how to mesh a part, how to mesh a system. And by learning one software will help learn different other softwares. Once we know or once we are familiar with FEMAP, we can learn hypermesh or ANSA within a shorter duration, because we do not know which company is using which software. So when we are learning in a graduation, we can have a taste of some of the softwares like FEMAP. Then you can easily learn other softwares like hypermesh and ANSA wherever you are going to be joining, if you are joining in a CAE domain. So FEMAP is available for free of cost for institutions. So institutions can take up the software and utilize the software for teaching and academic research. It will be useful for the future of the students. And some of the 2D and 3D simulation softwares like Nastron, ANSYS, Abacus, COMSOL, etc., whatever present in the list, and many more softwares are available. Basically, there are many different softwares available. However, Nastron, ANSYS, Abacus are widely used, and HyperWorks are widely used in industrial applications. So learning such softwares will help us, will help you to getting into a job into a R&D or service sector companies like that. So there are many open source codes available, as well as many software available for students. So it can be utilized for your research works, academic projects, with which you can showcase your experience in the company interviews. So it will help you in that way. And many companies nowadays provides free license for limited period, like 1 month, 1 year, 6 months, 3 months of license are available. So you can take any of such softwares and you can learn and you can showcase your competency in that tools. Because nowadays, as we have seen the industrial revolution, like we are moving towards industry 4.0. So it is all about the digitization of the system, environmental system, that will improve value of the product through softwares and hardware development, hardware technologies, whatever we have, like cloud computing, IoT, such techniques are widely being implemented in many industries. So we are in the situation where that application of softwares are highly used for product development, and learning such tools are very important to get into a uh, company or getting into a job after your graduation. So the knowledge of tools are very much required when you are coming out of an institution at this moment. And the future, we can see definitely a growth in this field, because all the industries are moving into a industry 4.0 revolution. Everywhere, the application of software are getting increased, and the technology with every software is also getting improved every year. So as they increase the capability of tool, we have to improve our competence in that tool. So in that way only we can increase the employability in the near future when we are coming out of the college. And there are many opportunities in the computer-aided engineering domain, because basically the computer-aided engineering is helping us improving the product quality, product performance, basically a value engineering to a product. So this is contributing more to improve the value or improving the value of a system in industrial environment. So there are many opportunities or many job employabilities are there in terms of meshing, in terms of structural thermal analysis, static dynamic analysis for various tools. So job opportunities available for different tools. So understanding any one tool will help us understanding different tool if we are going into a different company where we use different where they use different tools. Then understanding of fundamental theories and fundamental behind the tool will help us learning the new software. And there are many employability there in CFD, NVH domain, and kinematic analysis, crash analysis for automotive sectors, and many more opportunities are there. So basically what we understand from this discussion is like the design decisions whenever we do or we develop a new product from the concept. So all the design decisions can be made based on the performance which is evaluated in a virtual environment. So that will improve the value of your design, value of your product at an early stage of the development. So we need not wait till the proto built and test and validate in a real situation or real environment or real test rig evaluation. Because any changes required, we come to know any changes required after building a physical proto, it will cost more to build another one modified version of the same proto. So those cost and time can be drastically reduced by implementing the computational methods, computational approach, what we are currently using in the industries. So tools and methods are available. However, we cannot completely eliminate the physical evaluation, but however, we can drastically reduce the number of physical testings through the virtual simulations. So that is the understanding what we want to have. And by simulating with appropriate input, any risk involved in the product can be understood at a very early stage of the development. That will help reducing the cost and time of the development. It will improve the product to market time. And many sophisticated tools available which will integrate the various approaches like 1D simulation to the 3D simulation and one-dimensional simulation to the 3D systems and multiphysics systems, which will help us to understand the system's performance in more realistically. So meanwhile, it is also required hi-fi hardware capacity and software, dedicated software for the simulations. So when we do simulations, it also should be considered along with the manufacturing process. Though we study all the design, like a CAD drawings and everything, we should also correlate how that manufacturing process influence the design what we are making through the basic design. So we should fine tune the design by changing the input based on the manufacturing process. So it is like a correlate. We have to correlate all the process involved in the system while we develop the virtual models, because virtual models perform the performance what we are extracting from the virtual model. It is basically based on the given input. So as you assume various input, it will reflect on the response. So we have to refine the input, and we have to refine the assumptions based on the manufacturing processes and design processes. And then we can get more realistic output. So this is how you can improve the product value through a virtual environment. So CAE is one of the approach or one of the domain in which we can expect such value improvement to a product at a very early stage of product development.